Hello and welcome back to video 2 for topic 2, computer organization. Here we're going to be describing primary memory, and this is for the IB Diploma in Computer Science. As you can see, 4 core units, and we're on to topic 2. We've done the first one, the CPU architecture, and now we're going to be looking at primary memory. So the objective, by the end of this presentation, you should be able to understand what primary memory is and its role in computer systems, differentiate between two types of primary memory, these are RAM and ROM, and explore the need for primary memory and its relationship with the CPU and secondary storage. You may be familiar with this as an example of RAM. So primary memory is part of the computer where data, programs, and instructions are stored for immediate access by the CPU. There are two main types of primary memory. These are RAM, which is volatile, which we'll come to, and ROM, which is non-volatile. Primary memory is stored on the motherboard, making it easily accessible by the CPU, allowing faster read and write operations. Okay, so what is primary memory? Okay, primary memory is the only memory that is directly accessible by the CPU. It holds both data and instructions that are currently in use by the system. Primary memory is also called main memory. It has quicker access times than secondary memory and is slower compared to cache memory. So just to talk to you a little bit about RAM, RAM, as I mentioned before, is volatile. It loses its data when the power is turned off. So when you turn your computer off, whatever's been loaded into RAM, okay, goes. The RAM is emptied. Okay. Obviously, it can be overwritten with new data and instructions, whatever the CPU needs or as the CPU is working on at any one time. It holds data and instructions temporarily during execution. Example, unsaved document changes will be lost when the power is turned off. So, as before, and I'm going to show you the diagram from video 1 as well. Okay, just to go back to the schematic from video 1 of the CPU and all the parts of the CPU, the arithmetic and logic unit, other registers, obviously input and output controllers, links to the storage device, the MAR, the memory address register, the MDR, the memory data register, and the control unit. And you can see we've got all these buses, data buses going through cache, but are all linked to RAM memory, okay? So the CPU is getting the data. Obviously, this is fetched from RAM into the CPU to be decoded, and then it's executed and sent to either an output device or back to the storage device or back into RAM. So that's going back to video 1 and the CPU and how they are both linked together. Primary storage, RAM, and the CPU, okay? So the CPU takes data and programs held on the hard disk drive, or the SSD, the solid state disk drive, and puts them into RAM temporarily. This is done because read-write operations carried out using the RAM are considerably faster than read-write operations to backing store, i.e. the hard disk. Consequently, any key data needed by the application will be stored temporarily in RAM to considerably speed up operations. Okay? The other type of primary memory that we need to learn and understand is ROM, read-only memory. Okay, a little example of a ROM chip here. ROM chips are non-volatile. They retain data even when the power is off. Okay, so data cannot be overwritten or changed easily. It's fixed. Okay, whatever's on this ROM chip generally remains on this ROM chip. It's used for storing system-critical data, like the startup instructions for the operating system. Now, why is it important? Well, primary memory serves, as we looked at in the previous part, serves as a bridge between the CPU and secondary storage, like the hard disk drives. Efficiency. It minimizes the access time for processors ready for execution. All data, programs, and files are stored in secondary memory, in secondary storage, which has slow access times. Before execution, the operating system loads these into primary memory, which is faster. Only active processors are loaded into primary memory, allowing the CPU to access them quickly and efficiently. So, what are the differences? Well, primary memory has got direct access from or by the CPU, whereas secondary memory hasn't. Therefore, it's faster. Volatility, RAM is volatile, ROM is non-volatile. And usually, secondary storage, well, most of the time, is non-volatile. Capacity, generally a low capacity, 32, possibly 64 gigabytes in terms of RAM memory, but secondary memory, obviously we're working in terabytes now. Examples include RAM and ROM for primary memory, and for secondary memory, the hard disk drive or the solid state drive. So in summary, primary memory is critical for fast execution of programs and processes. RAM allows temporary storage of data for active programs, while ROM retains system critical instructions like boot sequences. The CPU directly accesses primary memory, optimizing system performance by reducing access time compared to secondary memory. As always, we have 3 exam-style questions. Question 1, define primary memory, 2 marks. Question 2, describe the difference between RAM and ROM in primary memory, for 4 marks. And finally, for 8 marks, explain why primary memory is essential for the functioning of a computer system. Okay, so if you don't want to see the answers, pause the video, have a little go. Otherwise, here we go. So for 1 mark, you mentioned it is directly accessible by the CPU. For another mark, you mentioned it stores data and instructions currently in use. RAM and ROM, 4 marks. Identifying RAM is volatile memory. Identifying ROM is non-volatile memory. Identifying that RAM can be overwritten with new instructions and data, and explaining that ROM stores instructions that cannot be changed, or generally speaking, cannot be changed. And then finally, I've given you the mark scheme here. 1 mark for stating that primary memory is directly accessible by the CPU. Another mark for explaining that primary memory holds data and instructions currently in use. 2 marks for explaining the role of RAM in temporary stored data and instructions during execution. 2 marks for explaining the role of ROM in storing system-critical data that remains after power is lost, e.g. the boot-up instructions, startup instructions. And then finally 2 marks for explaining how primary memory optimizes system performance by allowing faster access to data compared with secondary memory. Okay, that is it for this video. It's been quite a short one. Hope you've gained something from it. Until the next time, bye for now. Please continue to ask questions, leave your comments, hit notifications, and please subscribe. And finally, if you wish to buy me a coffee, I'd be truly grateful. Please visit buymeacoffee.com/learning zone. Thank you very much indeed. See you next time. Bye for now.